Okay, so we are recording now. So let's get started then. Thanks for coming to everyone who's here. The idea is just to use this as an office hour to have questions. Sessions are not compulsory. So that's why we are not going to be covering like new material. That is more like to at least today is going to be questions you have about the material so far. That would be, I mean, it's a good opportunity. So guys, let me know. Is there any question about the homework, about the materials, about the topics we have covered so far?
Hey, Professor, I don't know if it's just myself, but I cannot hear you very well. It's like
Yeah, I think it's a problem with the audio teacher
Okay,
because we can hear you. It's like a little bit. We can hear you a little bit, and then it's not possible. So
okay, let me have a look at this. Let me
thank you so much.
uh, let me move the microphone closer to me. Can you listen to me better now?
Yeah.
yeah, I think so. Yeah.
Yeah. Okay, thank you. Thanks for letting me know. I think the microphone was like too far from me. I just moved it like more in front of me, and I think this is working better. So I was only saying that we are going to. The idea is to answer questions that you may have, comments about the materials we have covered so far, homework, or I don't know, doubts in general you have about the class. So do you have any question about the homework, about the materials, anything you would like to ask or comment on or say?
I have a quick question regarding
Yes,
the
yes, please.
activity 1A. Even when it won't count, I mean, there are no points for that activity. Do we need to upload our Juniper notebook or not? To Canvas?
Yeah, I'm trying to think. Is there an upload button in the activity? Does anyone? I don't remember if there's.
No, it's not.
No, then I think it shouldn't matter. I think 1A is just to then
Try
you
to understand the scratch of the neural network, right?
exactly. Yeah. And then you're gonna use it for 1B, which is the one that
Yes.
counts.
Regarding that topic, for 1B, what I understood is that it's okay if we like copy some of the code from 1A to make it useful for us to 1B. I mean, it's kind of the same, I guess. Well, I already start working with my team and that stuff,
Yep.
but I think it's the same, right? The first one is classification or to identify numbers, and the other one is to identify like sign languages.
Yeah. It's exactly the same. It's exactly the same. You might have. I mean, you can definitely copy the code and it will work. I mean, there might be a couple of changes you have to do.
Yes.
My suggestion is will always be try to do 1B without looking at 1A. And
Yes.
that would show that you actually got it and without looking. I mean, even if it's replicating it, or you might change the sections you consider that you can improve. That's perfectly fine. I mean, the easiest way to do it and fastest would be copy paste and change a few lines just to make it work with the new data set.
Yes.
The suggested way would be, okay, try to do 1B without looking at 1A. And
Yes.
then whenever you have a doubt, then you can have a look at. That would be my advice.
Yes, that's what we did. Like in our team, everyone was by its own trying to start from scratch.
Yeah, exactly.
Of course, it's explained also in the videos, in the YouTube videos, right?
Yes.
It's also okay. That's how we did it. Another question, and it worked. As you said, you have to change some lines and something from our stuff to make it work. And one question that I had, when I was trying the model just in the training loop, I was using the same parameters as 1A, just to begin. But I saw that 20 epochs I guess it was too much for the model because from epoch 7,
Mhm.
the accuracy didn't change that much. So I was thinking, is it okay to reduce from
Yeah,
20
absolutely.
epochs to 7?
Yeah, absolutely. Yeah, actually, you may you can expect that to happen at some point. Especially well, not especially. This is both data sets are kind of simple. The one in 1A is very simple. The one in 1B is not so simple, but still is not that very complex. So it is not weird that you see that. Now, having said that, when you're actually training and you want to maximize performance and you want your accuracy to be like as high as possible, depending on what's the result you need, you might actually, I mean, try a little bit harder. Like for instance, and this is something that well, we haven't covered so far, but there are techniques like to track how the model is behaving during training. And depending on what you get, you may try to do some things. Like the most common thing to do is to adjust the learning rate during the training process.
Okay.
Whenever you see like this kind of plateau behavior, depending on what you are getting as a result, you might say, okay, I do early stopping and I finish my training and that's it. Or you might try harder in case that, okay, it's not improving, but I'm only 70% accuracy, I'm only 60%, whatever. And this is not good enough for my problem, then you have to try harder. And then you might try changing the optimization process. You might try doing some sort of, it is called like learning rate scheduling or scheduling.
Okay.
So you adjust the learning rate throughout your training process. And that's
Okay.
usually something that you will do like in most cases for like for real applications. That's something that you might have to do.
Okay.
Adjusting the learning rate as long as you during your training. I mean, that's something that is very common to do. Usually the simplest one would be like whenever you see a plateau, usually in the loss function, the most common thing would be like to decrease the learning rate by a little bit. It might be as simple as multiplying it times 0.1 or something like that. Or you can do something a little bit more fancy, like you can even adjust the learning rate to follow more complex functions like sinusoidal functions and things like that. I mean, there's a lot of literature on how to adjust learning rate, but that's what you would do. In this case, I think it's enough. I mean, probably 20 epochs is too much. And you can try, for instance, sometimes if you see that the loss function is not like jumping a lot, like it's okay, it's jumping a little bit, but it's kind of stable, then you can stop it. If you see that this loss function is increasing or something like that, then that usually is an indication that the learning rate is too high. And then you can try decreasing the learning rate and trying with a smaller learning rate.
Okay. Okay. Thank you. Another question. Sorry.
Yeah, please go on.
Try to add. Is it okay if we add like another layer to
Yeah,
the
absolutely,
model?
absolutely. You can try layers. You can change the number of neurons. You can do whatever you want to do. Yeah.
In the layers, it's always the same procedure, right? The input to the neural network is going to be 784 because it's the pixels of the image.
That would be the first layer. That would be the first one. Yeah.
And then I have just a question, and it was because for the model I copied from the 1A. The output, which is going to be from the first layer, it's 200.
That's just the number of neurons that that I decided in that example, right? 200 neurons in the first layer.
But we can also adjust that to be
Absolutely.
less or higher.
Yeah, absolutely. All those numbers, except for the 784, which is the number of pixels in the images.
Yeah,
all the other numbers, and also be careful with the last number, the number of neurons.
It has to be 24 because of the 24. Okay. And regarding the 24, you removed, in the code, it was removed 2 of them because it's not included in the sign languages, I guess.
No, it was because it's the J and the Z, and the J has they have movement, so you cannot recognize them in the J is like this. I mean, you have the movement like a J, and the Z is like this. So
Okay.
you draw like a set. So all the other letters are static.
Ah,
Those
okay.
two have movement. So you cannot. There's no
Uh,
way that a picture captures if you're doing captures this movement, right? Because it's only a picture. That's the reason.
Okay, that is why.
Yep, that's the reason. Yep.
Okay, those were the questions we had in our assignment. Thank you, Professor.
Oh no, thank you. Thanks for asking. Thank you. Brian, I think it was you the next who had the hand raised.
Yeah, hi, Professor. Good
Hello.
evening.
Good evening.
Yeah, I just wanted to confirm if I understood correctly what you said. So you were saying that if the cost value that we are getting in each epoch jumps, like changes too much up and down, that means that the learning rate is probably too large. That's what you said?
It's the most common reason. I mean, it's not the only one, but it's the most common reason. I mean, like you would expect, like I was mentioning this last time, like if you would expect that let me get a little bit of, see if I can use my, where is it? You would expect that the learning rate actually behaves a little bit like this, like that is doing something like this. But in general, you would expect, where is the to draw here? I cannot see the annotate button. Where is it? Notes, no. Stop. Share. Yeah, share is in share. I guess. Yeah, let me put a whiteboard just to, it will be probably good to have
Sure.
to draw a little bit. Thanks. New whiteboard, yeah. Can you see the whiteboard? Yes, can you confirm?
Yes.
Yeah. Okay.
Yes.
So I mean, if you see like loss functions or cost functions, and you see, this is something I was mentioning last time. So I apologize if I'm repeating for people who were here last week. You would expect that it's like this, no? Like that would be in the ideal world. That's the way a loss function would behave. But this never happens, and it would be really suspicious if that happens. I mean, that's not expected to happen. So, but a good loss function would be something like this. Something that is like a little bit jump, because you're using mini batches. So every mini batch will have some sort of, not some sort, will have some randomness, and that randomness, due to the selection of the images, there will be images that your model can recognize better than others. And so those mini batches that don't have many of those images that are nice to your model or that your model likes for some reason, then you will have a little bit of a higher cost, but then you will have some better and so on. But in general, you would expect that the model will be learning, and in general, you would expect that the trend is like that. I mean, it's going down. So that's okay, and this would be like a very nice loss function. I mean, this would be really nice. Is like properly training. In general, I mean, for this model that is very simple and very small, you wouldn't worry much. But if you're training something larger, you would expect that, okay, you're going something like this, like this, like this. And maybe at some point it's going to plateau. Like you will see that the loss function is not changing, right? And say that this is a big problem. Like it wouldn't be the case for these simple problems, but something that you are training, I don't know, you have been training for 3 days maybe. And then after 3 days of training, you see that something starts behaving like this, right? So at that point, you have different options. And this is aligned to the other questions, to the previous question. Like at this point, you would say, okay, this is the loss function, but you also have the accuracy. So you might be able to measure what's the accuracy at this point, and the accuracy might be something like, I don't know, and you might have here like, I don't know, say 95% accuracy for this loss function. You care about this. I mean, this is the result you are reporting, but the loss function is a really good indication of how well your model is training. So you get 95%, isn't just an example, 95% accuracy with this loss function, and you see that the loss function has kind of plateau. You could say, okay, I do a technique that is called early stopping, and you stop the training. And that's it, no? And then you're happy because 95% is good enough for you. Now, if you see something that is not like so good, and you see something similar to this behavior, but now you're getting only 75% accuracy. 75 and 75 is probably not good enough for your problem. Then in that sense is when you start looking at, okay, I might reduce the learning rate and it's usually something to do with adjusting the learning rate. Now, regarding more related to your question, if you see something, okay, this training is good, this training is good, this training you might adjust the learning rate just to try to have something that goes is going like this, and then maybe adjusting the learning rate will help you to go like this and then down again. That's what you usually try to do, like kick a little bit learning rate, and sometimes it's not only reducing it but increasing it so that you get like this and then you go down again. So that's why you have like these learning rate schedules, like to adjust the learning rate during training. All that is common during training and is part of a good training process. If you see that the loss function is too jumpy, like, okay, the loss function is more like this, even if you see that there is a little bit of reduction, but it's too jumpy, this might be an indication that the learning rate is too high and you need to go lower with the learning rate. Yeah. So something like this, yeah, this most likely learning rate is too high. Basically. I don't know if this helps with your question.
Yeah, I think that's clear. I have a follow-up.
Yes, please.
What happens, or what does it mean if we have like a cost that is it's going down overall, so it looks like it's going great, but the accuracy it's flat in the last epochs?
Yeah, that also happens a little. That can happen. Let me try. I'm trying to raise this thing. That in general, and this also, that's a little bit more tricky because in general, I'm trying. If at least the intuition is that if the cost function is still going down, you might get a little bit more accuracy if you allow the model to keep training. In general, that's the expectation. But training models many times turn more like I don't know, there's a little bit of an intuition when training them, I guess. And sometimes you see that, I mean, you have been training it for a while, and you see that the cost function probably is reducing, but the accuracy is kind of plateauing, like reaching a plateau. Then you could try doing something. I mean, if you need the accuracy to increase, then you might try something else, like adjusting the learning rate would be the first thing to do. You could try something totally different, like changing the optimization algorithm. Like so far, we have only seen a stochastic gradient descent. I mean, there are better ways to optimize the model, like variations of a stochastic gradient descent, but still that will lead to better results, like particularly atom and variations of atom. Next week tutorials are on that. So if you're doing like, okay, you're using a good optimization algorithm, like not as simple as a stochastic gradient descent, and you see that the loss function is reducing, but the accuracy is kind of achieving a plateau. In general, the expectation would be that if you keep training, the accuracy should improve a little bit. I mean, like the model has room to improve. That's why you don't only check the accuracy, you also check the loss function. But also it might happen that even if you see the loss function reducing, you might see that the accuracy, even if you keep training, you see the accuracy that it just stays flat, or not flat, but very, very similar, right? So, and in that case, and if you still need to improve the accuracy, then you have to try something different, like changing optimization algorithm or the learning rate schedule, the learning rate, schedule. That's also something you can do. And by that, I mean like because I haven't mentioned it, this, if you plot I mean, if you had a plot that was the learning rate versus this is an L, learning rate, versus the number of epochs, or iterations. This is really bad, this whiteboard. So the way we have done it so far is that the learning rate is, I don't know, 1e⁻3, something like this. And then is the same, is constant during the whole training. And then you will see that the loss function might be behaving something like this. Just to say an example, okay? And for this, let's say that you completed 100 epochs. That was your whole training, and here you finish, and then you're happy with your accuracy and everything is fine. Now, when you need still to improve, I mean, like better optimizations algorithms allow you to change the learning rate during training. And so your learning rate might be something like this. But at some point, say something at this point in time, you adjust it to something like this, and then you go like this. And then the whole training period was, rather than staying flat, constant the whole time, you did this kind of adjustment. And it was because at this point you saw that there was a kind of usually use a condition like on plateau, precisely, like if there is no more change than 0.2% during the training in the loss function, or 2% or something like that, I don't know, a small percentage, and you see that the variation is less than that percentage during a certain number of iterations, then you can, okay, just multiply the learning rate by 0.1 and then reduce it, or by 0.5, reduce it by half. That's kind of common. And there are other more fancy things, like one cycle policy is one of the best ways to adjust the learning rate, and that's more like, there's going to be a tutorial on that. You go more like this, something like this. You start very slow, then very little, then you start increasing the learning rate, and then and like at 40% of the total number of iterations, you reach like a maximum, and then you decide to, oops, what happened here? And then you just start decreasing it, and things like this work quite nicely. I mean, it's an active area of research, actually, how to improve the training of the model. Yeah, and then also depending on the number of training a model as small as this one. In general, the models that we train, even in real life, tend to be small. I mean, that you can train in 1 hour, 2 hours, something like that. But if you're training like an LLM, then that has that is in the trillion token, and then number of tokens, and then billions of parameters, the training is a different. I mean, training that is totally different. I mean, because well, not totally different. The principles are the same, but then you will see things that, okay, the loss function is like this, but then after 8 days of training, you see something like this. But then by the day 20 of training, you see that it starts going down. And there are things like a lot of weird behavior, but that's in the very large scale, and that's something that's different. So there is not a unique answer. Is the basic answer to the question.
Right. But this is super helpful. I think there are a couple of things at least we can try right now, and
Okay.
then next question we can look at the optimization algorithms that you say. But yeah, this is great. Thank you.
Yeah. Okay. No worries. Thank you for the question. Jorge, the question?
Yes, Professor, thank you.
No, thank you.
So I was wondering if, well, in our case, the cost was dropping while the accuracy was improving, but only marginally after epoch 12, I guess, or 13.
Yeah.
I don't know if could be this a sign of slight overfitting, or what do you think?
I don't think. Well, no. I'm recalling the data set, and definitely that model is going to. You will have overfitting in that model for sure. For sure, that there are two things that we have to consider. Is that the first one is that even when the model is kind of simple for today's standard, not the model, the data is kind of simple for today's standard. You still have 24 classes, and you are using only linear layers. So even for this kind of simple data, the model is not powerful enough to learn to represent or it's not powerful enough to correctly classify the data. So definitely there is going to be some overfitting in this problem. Actually, one of the things we're going to do by week 7 is that we are going to do an NVIDIA workshop. And one of the problems we're going to do, like the first or second problem, is going to be this particular exercise. But then you're going to be using convolutional neural networks for that data set because precisely the model is not good enough. So you will analyze this data set a little bit further in that workshop. But yeah, there is definitely going to be some overfitting for that particular data set.
Okay. And the other one I have, it's how common it's to explore data augmentation. I mean, augmenting the data set, rotating, scaling, flipping. Is there something that it's possible?
Okay, for now we haven't seen it. We are going to study data augmentation. I think probably next week or in the future homeworks there is going to be data augmentation. You can actually absolutely, if you want to try it, you can do it. So just to make the point, I mean, in case some of you are not familiar with the data augmentation, the idea behind data augmentation is that synthetically, like computationally, you are going to do operations on the data so that you recreate more data. So flipping would be kind of ideal for this kind of data set because if you have, I don't know, a letter that is like this, probably if you do it with the left hand or with the right hand, then you're going to have like this kind of horizontal flipping and it's the same letter. So in that sense, you could try, if you wanted to try data augmentation, you can do it. And that's what data augmentation is generating that data, more data artificially. Also in the workshop that we're going to do, we are going to do some nice examples with data augmentation using PyTorch. Yeah.
Okay.
Yeah, but you could try. You could absolutely try augmenting your data if you want to.
Well, but that's
Flipping
something.
would be the probably some rotations. You have to be careful. The thing with data augmentation is that you have to be very careful that you don't do things that, I don't know, 90 degrees rotation and then you have a letter like this. And that would be like unreal, right? So, but if you have it like slightly like this, probably that's still possible. So just to be careful with that, to be within the spectrum of real possibilities.
But that's a subject that we will cover in the following weeks, right?
Yes, absolutely. Yeah.
Okay.
Yeah.
Thank you very much, Professor.
No, thank you for the question. Yeah, good questions. Anyone else that has any kind of comment or question?
Hi, teacher.
Hello.
Me. Hi. I just want to ask if you can share on your screen an example of the documentation of Python that you suggest us to apply to our notebooks. I remember the last class you told us something similar to
Okay,
that.
okay.
Like,
Yeah,
I don't remember the concept, sorry, but it was something related to Python documentation, something
yeah,
like that.
let me probably how do I will stop the board. Can you still see the board or
Yeah.
you can still see it? Let me. Okay, yeah, I found it.
It's
Let
gone.
me just share my screen now. What I was saying is that let me. Desktop. Let me put this bigger. Can you see my screen now?
Yes.
So what I was saying is that when you're asked about the commenting or commenting, that something that I would advise you, like the expectation would be for a good comment would be to do like doc strings in Python. Sorry, this is the keyword is in Spanish. Let me just change it. So what I was saying last time is that if you do something like this in the comments, that would be really nice. Like if you see like, for instance, any, let me see if there's a function, Python function here. Like if I say that I'm gonna import, I don't know, random, just to say something. I haven't run this, so it's gonna take long. Okay, so now if I wanted like to use the random function, and I'm just using this example as an example, right? And I'm gonna put something like here, you will see that there is a documentation here, right? And you can see that, okay, you have some documentation for random variables generator, but well, if I random.rand int, and I do this, you will see that there is the help. And if I do shift tab, I don't know if in Colab it works. Well, in Colab it doesn't work, but you can see this kind of help here, right? Like the input, well, the parameters are A and B, they are integers, and the function is going to return a random integer in a range A, comma B inclusive, right? Including both okay. So that documentation that you see, that little bit of comments that you see will be the contents of the docstring in that document. So in that function, sorry. So if you go to the function random.randint in Python, you will see that there will be, the random function will have something like, say that there is the class random, and there is the, no, better I don't do this because I'm gonna screw this. So if you go to the documentation of that function, you will see that there is, at the beginning of the function randint from the class random, there will be something that says this kind of information, right? Which is a docstring. The comments that are at the beginning of a function, like say let me do it with another example, with a simpler example. That would be, if I define a function that is called sum, yeah, let's write it like that, and I have a comma b, and then my function is return a plus b. That's a very complex function. But say that you have this function. Oops. The documentation, what's going on? The documentation in this function, if you happen to see a similar function in Python and you look at the documentation, you will see that at the beginning there is this kind of comments that says A is or it says like input A is an integer, and then you have B is an integer, and then the output would be output is the sum of the provided integers A and B, right? So this is the kind of comments that are adequate for to be nicely graded in the homework. And it's something that describes what the inputs are, what the outputs are, what the function is doing, right? Sometimes you can go as granular as commenting line by line, but not all the time. Sometimes only commenting at the beginning of the function. That's the kind of comments that we are expecting. That's probably what I was saying last time. And just to finish, I mean, these kind of comments at the beginning of a function or a class that go in quotation marks are called docstring. So that's why I'm saying, like, if you add a docstring to the functions, that's usually a good thing to do. Like if I was going now to call the sum function, if I say summa, you will see that the comments, the help that appears here in the function is the docstring of the function. You will see that input is an integer, b is an integer. It's exactly what I wrote here, right? So whenever you see that help in any function, that will be the docstring of the function. So that's why it's always a good idea to correctly comment your code by adding docstrings, because whenever you call the function, you will have the option, you will be shown this kind of information, which is kind of useful. Well, not kind of, it's really useful.
Yeah.
Just to recall.
And nice.
Yep.
Looks very good.
And can
Thanks
we
so
add the comments wherever we want in the function?
You can add the comments wherever you want. I mean, my suggestion would be do the docstring, because that's like, for instance, if you are doing this sequential layers, you can see, you can comment something here. This is a class for whatever, for doing sequential layers. And then you can have def init, you say, okay, layers containing the different layer objects that your model is going to be made of, whatever. I mean, my suggestion would be for every function and for every class, try to do a docstring that describes what's the inputs and what's the output. And then if you want to comment more granularly, like if you wanted to comment, okay, this line is doing this line is enumerating whatever it is enumerating. Well, what is it's just that I changed to whatever you want to write per line. That's also totally fine.
Okay, thank
So
you.
I think
Yep.
it's even better if we do both, right? It's
Yeah,
like
absolutely,
the
absolutely.
best scenario.
I would say so. Yeah, I would say so. Also, if you want to add, like, also recommended if you want to add, like, okay, I also not only want to do this, but I want to use. It's just that I if you want to use like text and say and draw a picture. Okay, this is ReLU class. Okay, the ReLU, and you can say something about the ReLU function here. ReLU is an oh, come on. You want
Oh,
to say
like
the
some theory?
rectified what?
Like some theory
If you
of
want
the.
to.
Okay.
If you want to, you can. A rectified linear unit is an activation function, and whatever you want to write, you can feel free to draw a picture of the ReLU function. You can do it. I mean, all that would be is part of the things that might increase your grade, right? I mean, in general, the idea is to the thing I said last time, and I will repeat, is that try to deliver the notebook as if it was a tutorial that you can present to someone to follow and understand a little bit of the notebook of the concept. Yeah, that would be probably the best I can say. Make it like if it was a tutorial, and it also will help you to understand better what's going on, I think.
Thank you so much.
No worries. Thanks for the question, Adriana. Yes.
Yes, thank you. Actually, you already answered my question because it was about including Markdown, if it was okay to explain our strategy or the steps we were taking, but you said it's okay.
Yeah,
right?
absolutely fine. It's absolutely brilliant if you do it. Even better. Yeah. Usually the homeworks that are the best graded because you sometimes get like the two ends of the spectrum, like some works that are like the very minimum and some works that are really a lot of nice pictures and things like that. So my suggestion would be try to do it like a tutorial, and then that'd be nice. And think of it like a tutorial for yourself, maybe for yourself of the future, if by any reason you want later to I don't know, if for any reason you stop working on this and then you want to take it in a couple of years, or you want to explain someone, try to make it like a tutorial to follow and remember these concepts, and then that most likely is going to be enough.
Okay, and a basic question, but I just want to clarify it for myself. So I understand on every layer, each one of the layers have to have the activation function, and then at the very end we have the softmax and then the loss function, right?
Yes, that's correct. So depending on how many layers you have, because where is it? Where is it? I'm creating the module. I mean, every layer that is not the last layer should have an activation function, because concatenating layers that are not followed by an activation function, in the end of the day, if you just concatenate linear layer after linear layer, you will have a linear layer in the end, unless you add a nonlinear activation. So every layer that is not the final one should have an activation function. Here we're using ReLU. I mean, in the past it used to be sigmoid. Now ReLU is still like the foundation one, but there are all other variations like HeLU, CeLU, or LickReLU. LickReLU is probably the most common one now. Variations of ReLU, right? Like but in general, you need an activation function that is a nonlinear. Then in the last one, usually you don't explicitly, like in this model, we are not adding the softmax activation function, because usually softmax will be implemented in the same function that computes the cross entropy function. And that's because since softmax is exponentials, I mean, e to the something, and then the cross entropy function is a natural logarithm, mathematically they cancel each other. And then if you implement them together, it's way more efficient than if you have them separately. That's why you will see that even the frameworks like PyTorch or TensorFlow usually present the model like this. The last layer is just a linear layer, so the outputs are going to be the logits, the linear output, and then it is during the training when you call the softmax, the loss function, that it will implement the softmax. So you don't usually worry about implementing the softmax function yourself.
Okay, thank you very much.
No, thank you. Thanks for the question. Yeah, every layer should have an activation function. Otherwise, it would be like a massive neural network for just a linear output. Yeah, like if you think just like in a tangent, if you see like ReLU, can I annotate here? Let me see. Oh, where is it? I cannot write on top of this. Oh, no, I can't. Like ReLU is like this, right? Like this. And it works fine, but now like leaky ReLU is like a simple variation when you have something like this, and then you have something, like a small gradient, a small slope for instead of just clipping them to 0, you have a smaller slope. This is probably 0.1, right? So negative values are not just clipped, they actually are multiplied by a little number. And more recently, like in models like GPT and these kind of models, they use something called CELU or HELU. No, sorry, HELU, which is, I don't remember exactly what's the G for. It's like gradient, but it's more like it's something like this. It is like this, and then it has like an exponential here, and then it goes like this. It's something like this. It's like, so this part is linear, this part is more like an exponential function, and then it gets like very small. But there are different variations. And this is kind of a more complicated formula as to learn for. Yeah, variations of ReLU. Is anyone here from like electrical engineering background? Just asking.
No.
No, I'm just asking because the
No.
ReLU function, if you are from electrical engineering, you might recognize the ReLU function and you might say, oh yeah, really, the name makes sense. That's why I'm asking. Because it's basically the function of, maybe some of you might recall like an ideal diode, a rectifier. So that's where the name comes from as well, rectify linear unit. Because it's a rectifier, a diode, an ideal diode. Just something totally unrelated.
Mhm.
Let me stop sharing. I don't know. Is there any other question? Any comment? Anything else?
No, Professor. Thank you.
Okay, then
Thank you.
just as a comment, I will keep doing the sessions like this, like this kind of office hour. There will be some sessions that probably, because I was told that I cannot do more than 5 sessions, but as long as they are like this kind of office hour, then I think it's gonna be fine. So it's more like a session 2. I will keep doing it weekly. Only in the week number 6, there's not going to be anything because we have the quiz that week. But yeah, we'll continue doing this.
Okay.
Answer questions. Okay.
All right.
Okay.
Well, then, I don't know if there's no other question, then that would be all for today.
Sounds
Thank
good.
you.
Okay.
Oh,
Thank
thank you
very
guys.
much.
Thanks for coming.
Thank you, teacher.
Thank you. It
Oh,
was
thank you.
super
Take care,
helpful.
It
guys.
was
Take
really
care. Have a
nice.
good night.
Bye.
Bye.
Bye. Take care.
Thank you. Bye.
Bye. See you.
Thank you. Bye-bye.
Bye. Take care. Bye. See you. All right, then, guys. I'm going to stop the session. Thank you.